Welcome everyone, I'm Andriy, ex-Microsoft engineer. Today we are going to talk about Messenger system design. Previously we have built Stripe and Ticketmaster and people were pretty happy about that, so I think I should continue doing that. But rather than building the Messenger, today we are going to discuss all existing solutions on the public internet and why they are not working, including HelloInterview solution, including system design, interview, book, and solution from there, and a bunch of other solutions from the forums, because of course I've asked a lot of questions to the forum, so I gather all the feedback and all potential solutions from the people. Let's go. I also need to mention that I was consulting with principal engineer from Microsoft and staff engineer from Snowflake, discussing and asking their advice about the solutions that I'm gonna discuss here that are on the public internet. They both confirmed that yes, it's not going to work. It's not linearly scalable, so probably they're using something else. Or maybe this is not the problem. So being linearly unscalable is a good way of doing stuff. I don't know. As we always do, let's define functional and non-functional requirements. In this case, since I want to put your attention in the specific bottleneck that is everywhere on the solutions, we are going to have some shortcuts for the functional requirements. So, user is able to select chat where he or she wants to communicate. It means reading and sending the messages. User receives near real-time updates only if he or she is online and only if he or she currently has the chat selected opened. So we don't care about real-time updates on the other chats that are on your contact list. Just remember this. And now the bottleneck. I would aim Telegram functionality, which means we have 200K participants per chat, and we have few millions of participants in the channel. And channel means that there can be one person who is doing posting actually. But the problem is that under every post there is a comment section, and all these 2, 3, 5 million of people can go to this comment section and have near real-time functionality of the chat under the post. So it's pretty much, I consider it as a chat still. But even 200K participants is enough to kill every possible solution on the internet that I've seen so far. To simplify that, we are going to have only 1,000 chats. Every chat has 10,000 participants, which is way less than actual possible number of participants. Overall, it's going to be 10 million users. Because, as you remember, we count only the users that are currently online and currently in this chat. Latency, of course, we're gonna aim as minimal as possible, so probably we are going to use some real-time communication like raw TCP, WebSocket, stuff like that. Main requirement that is never satisfied for all the solutions I've seen is to be linearly scalable, which means if we double this thing, if we add 1K more chats and we scale our infrastructure twice as much, it will still be able to handle all the load. And one small note, encryption would actually kill everything whatsoever and will make every possible solution not linear. To be honest, if we consider user-to-user private key, if we consider encryption on the chat-based private key, it can be a bit better, but still, I don't think Telegram provides any encryption for the public channels, and I don't think it provides any encryption for large channels or chats. So we consider we don't have any encryption at all. So I'm going to depict a single chat as the following. So we're going to have a rectangle with the chat ID, and this chat contains all the users that are both online and both connected into this specific chat. So they have this chat opened in their mobile, web, whatever. In this case, chat 1 has 4 users that are currently online and can send and receive messages in this chat. Second thing, gateway. Gateway means it's real-time WebSocket server stateful. Why WebSocket? Because probably we need to support browsers, and for browser, most probably the most viable technology is WebSocket. You cannot do raw TCP for now. That means it is WebSocket server for sure. We might also have a queue, which is pops up natured asynchronous communication way, which means it can be some publisher who injects the event here, and there can be one or more consumers that are consuming events from here in fully asynchronous manner. As a queue, we might use Redis pops up, Kafka, RabbitMQ, MQTT. They have different guarantees, but overall, we just need to understand that this is going to be pops up asynchronous way of communication. For simplicity, we are not going to send messages through gateway node or through any real-time server that users are receiving messages from due to latency. Why? Because it will be easier to calculate the load and to actually show you the bottleneck. Second thing, it is fully decoupled from our system. It is separate, it is stateless. We don't need to care about its scale because it's trivially scaled by replication. Keep in mind that we are going to choose the same color for chat ID as a participant and chat ID for IP. So in this case, if this is chat 1, it actually should have been green rather than white. Or this guy should be white rather than green. Next up, we might have different storages. For us, it can be also anything. It can be Postgres, MySQL, NoSQL, Redis, key value, whatever. For us, it doesn't really matter what it will be. The only thing that matters for us is how we are going to shard it, because typically we are going just to store key value pair, so you can choose whatever you want. One more thing that I would like to discuss beforehand is how we are going to connect to real-time WebSocket server called gateway node. So mainly we have two ways of doing that. First one, I call it random. So how it works, user client, user 6 in this case, to the load balancer to gateway node HTTP endpoint. Gateway node 2 is going to write that this user 6 is going to be owned by me. And we write it to some sort of storage. And then we return it as a response that, okay, here's my URL, gateway 2, and you're going to connect to WebSocket this time to me directly without any load balancer. So this way we are connecting and we keep this connection. If somehow some race condition happens or something like that, we always have source of truth, which is this guy. Whenever user reconnects due to deployment, crash, failure, whatever, new node that is going to be connected to is going to write itself as a new owner of this user, so the system generally should work fine. Why not to do it through the load balancers all the time? Because load balancer level 7 is going to terminate TCP connections, which means they are not stateless anymore, and we have a lot of problems of scaling them. If we choose load balancer L4, which is TCP only level, it means we have only 5 tuples for load balancing, which is source port, source IP, destination port, destination IP, and protocol, which is going to be TCP in our case. The thing is that it is much harder to make a load balancing decisions if we want to do it a bit wiser, or we want to use user ID for doing that. So it's generally possible, but this way, I guess it works much more in a reliable way. Second way of doing it is deterministic. So it is much more expensive and harder to implement, but it also exists in the system. So we are going to have some sort of coordinator. Typically, it can be some etcd, whatever, strongly consistent storage. This storage actually contains the consistent hashing ring. So you remember consistent hashing, this is going to be exactly the ring we are going to use, but to distribute the users to gateway connections. So this coordinator has this consistent hashing ring, and it is responsible for updating all the possible load balancers that users are going to talk to. So these users are, this is, by the way, load balancer L7 as well. User is connecting to this load balancer, and load balancer already knows where this user should be. So if this user even connects to different load balancer still knows that user 6, let's say in this case, is going to be connected to gateway node 1 because it's in this range, right? And then user 6 is going to directly connect it through WebSocket as well, but gateway node does not need to have any REST endpoint anymore because load balancer in this way is kind of router. The problem here that we need to maintain coordinator, which should be single replica in the system. So it is single point of failure. You need leader election algorithm here. You need strongly consistent storage. You need good way and fast way of updating all the load balancers to have the same consistent hashing ring data structure inside. Good thing about it that you also don't have this storage anymore, so you don't need to shard it, you don't need to replicate it. Your load balancers are going to respond and contain this information. And this storage is extremely underutilized in a way that only coordinator is talking to this storage. No matter which way we are going to connect to nodes, it still won't solve our problems. So just you can pick whatever you want, whatever you like. The first approach that we are going to consider before going to any PubSub related solutions is direct gateway append solution. This is only for visual part, but I'm going to explain it on the Excalibur before. So how it is going to work? let's first consider the very simple way of doing things. Let's say we have only chat 1. So we are going to remove these ones completely. And let's say we have gateway node 1 and gateway node 2. Two separate services. So definitely we want to distribute the users upon their connection. So let's say we are connecting via round robin, which means we are going to connect like that. So user 4 is going to gateway node 2, then user 3 to gateway node 1, user 2 again gateway node 2, gateway node 1. It is done so we can evenly distribute the connections between gateway node because we don't want any hotspot, right? So round robin is pretty fair here. Also, as we explained before, our random way of connecting to stuff is exactly going to do that way if we have a good random function, right? So let's say we have these connections to gateway nodes. Now, as was explained before, we need user to gateway storage that will store actually mapping user to gateway node. Amazing. Now also what we need to do, we need one more storage that is going to contain what users are participants in specific chats. So in this case, we have chat 1. So let's add this information here. We are going to have user 1, 2, 3, 4. Amazing. Now, let's assume we are going to insert new message here. So message comes from somewhere. Probably it will be coming from one of the users. Doesn't matter now which one. Chat API is going to resolve the users that it needs to send message to. We got user 1, 2, 3, 4. Now we need to resolve which gateway nodes are interested in these messages, basically. So basically what we need to answer here is which gateway nodes contain these 4 users. So we go here and we see that user 1 is gateway node 1, user 2 gateway node 2, and so on. So basically we need to only send this update to 2 gateway nodes. At the same time, it's going to be broadcast in a way. Then these gateway nodes, for sure in memory, they have some sort of mapping, which users are in which chats, pretty much similar to this one, but local to gateway node. And same, like which user has which socket connection handle, which is underlying operating system level of TCB, which is TCP block, I guess, which is 5-tuple protocol, source IP, source port, destination IP, destination port. So this information is purely in memory of gateway node. And now, since gateway node 1 received the update about this message, it's going to propagate this update to user 1 and user 3. As simple as that. But does it actually scale? My answer would be no. And now let's go to GIF picture and some other diagrams that will show why it won't be scaling. So on this GIF, you can clearly see that single message from chat API, it produces broadcast for all the gateway nodes. Fair point would be to say only in case we have participants per chat more than or equal to the number of gateway nodes. So it means if single chat will have only single user, it means it won't be a broadcast, right? So if I do this, of course, in this case, gateway 2 will not receive any update. That's fair. But let's return to our requirements. In our requirements, we have every chat has 10K participants. In Telegram case, it can be 200K. So it means we will always have number of users per chat bigger than number of gateway nodes, because typically gateway node can handle up to 100K of socket connections, which means that you don't really want to spawn 10K of gateway nodes, for the money reason at least, right? So probably you're always gonna have less gateway nodes than users per chat in this case, if it's not WhatsApp. And we definitely see that it is not scaling. You can now try with bigger numbers, and I actually built this emulation before. So I will leave the link to the GitHub in the description, but basically I have built a simple emulation that does what we just depicted in the diagram. So we have single chat, 10K people in this chat. We have 1K of gateway nodes. We have 1K of user chat shards, which is this guy. It is sharded by chat ID apparently. We have 1K of gateway, user to gateway shards, which is this one. Apparently it is sharded by user, and it also will be the problem if we spawn more these guys, we're gonna have the shards. If we have evenly distributed hash function, pretty good function, it's also going to evenly distribute these users. So it means for these 4 users, it's going to have user 1 here, user 2 here, user 3 here. And here we already have scatter-gather approach with sharding, which is not scalable as well. So not only we have scaling issue with gateway node, we also have scaling issue with user gateway storage, shards in this case. So moving back to this guy, we're gonna insert just 10 messages in this single chat. Let's run this simple emulation and see what is going to happen. So we get our stats. So let's see. We have gateway nodes, messages received. In this case, this is exactly this hop from chat API to gateway node. This is per node. So we got a bunch of percentiles, P50, P95, P99, all of them are the same because we were evenly assigning users based on round robin. So as you can see, in total, we have processed 10K messages. Why so? Because every single gateway node was receiving and was processing 10 messages. So it means every gateway node processes all the messages in this large chat. Do you understand why it's happening? This is a bit complicated picture. So in this case, we have chat 1, chat 2, chat 3. 3 chats, 4 participants in each chat. We have 2 gateway nodes. We have 3 chat APIs. It doesn't matter really. We can have single one, doesn't matter. So you can clearly see that due to round robin nature, every gateway node has at least 1 user in this chat connected to it. So it means this chat is going to be distributed between all the gateway nodes. So chat1 API is going to get a message. It understands that all the gateway nodes are actually interested in this message because this gateway node has 2 users from chat1. This gateway node has 2 users from chat1. They both need to get this message. Same happens for chat2 and for chat3. You can clearly see gateway node has at least 1 user from every single large chat. Now, you can say, but why it's not scaling? Just increase the number of gateway nodes, and this is what I did. Let's scale it by 2. And now, actually, situation isn't any better. Every gateway node is still going to receive update about every possible message from every possible large chat. Why so? Because round robin is still working, and every gateway node has at least 1 user from every single chat. Before that, it has 2 users. Now it has 1 user. Yeah, if we add 1 more gateway node, it will start scaling. But this is only due to the fact that we have more gateway nodes than users per chat. If we start thinking in terms of larger scale, so in case we have 10K users per chat, we have 1K gateway nodes, the math is pretty simple, right? How many users are we going to have for single large chat? 10K divided by 1K is going to be 10. So for one single chat, every gateway node is going to have 10 users from this chat. It means for single big chat, every gateway node is going to process all the messages. This is exactly what happens in this configuration. So we have one chat, 10K participants in this chat. We have sent 10 messages per this chat. And we can clearly see that gateway nodes, messages received, we have 10 messages per gateway node. In total, all the gateway nodes process 10K messages. Why? Because 1K nodes, every single node processed 10 messages, 10K. Then for every such message, gateway node sends it to 10 users overall, and that's why we have these numbers. But the problematic part here is this guy. Every single gateway node is interested exactly in all messages in all large chats. The problem here that if we have not a single chat, but 1,000 of such chats, and let's say we have 1 message per second in one chat, it means that every single gateway node is going to process 1,000 updates per second without any possibility of scaling. Because let's say we have 1K nodes and we scaled it to 2K nodes. So right now we are spending twice more money, right? But what will change from here? 10K users per single chat is going to be divided by 2K of nodes, which is going to be 5 users per gateway chat. It still requires this node to process message from this chat. This is for single chat, but for 1K of such chats, given 1 message per second, is going to be 1K messages per second per gateway node. What if we got lucky and we have more users coming to our service? We have more such large chats. We have 2K large chats. And now we need gateway node to process twice as much messages per second without any possibility to linearly scale it. And this is the problem, guys. This is not linearly scaled. All right, now this is my favorite part. I'm enjoying this a lot, and I will be enjoying right now a lot because I did research, I built the simulations. Now I can tell how it really works, but I've seen so many people telling me that no, you just need to put a queue here and it will be solved, it will be scaling, no problem. I don't know, for some people, for some reason, they think if you can put queue somewhere in your system, it automatically solves all your problem, which is not true. So let's see and observe all other approaches by people that were using queue. So we're starting with system design interview by Alex XU. I'm sorry, I'm not sure I pronounced it correctly. The solution here is to use message sync queue per user, as far as I can tell. Yes, so this is message queue per user, which is the worst possible way of implementing PubSub approach here. We can check HelloInterview solution as well, and this is marked as a great solution, offload it to PubSub, but not only to like some good message broker solution, but to Redis PubSub. Redis PubSub doesn't have any delivery guarantee. It doesn't have at least once. It doesn't have at least anything. So you just throw a message on the Redis PubSub and you just hope and pray it will get to your destination. This is extremely bad, but not only that, it won't scale either. So you're gonna overload your Redis anyway. By the way, they also have topic by user, not by chat ID, which is the worst way of implementing PubSub for Messenger. So let me explain you why it is the worst. So right now, how it's going to work. We're gonna put a queue per user. So whenever there is some chat message coming, we need to resolve only the respective users. And let's say we don't even care about how we map users to queue. Let's say user ID is the topic, and we have some sharding or partitioning mechanism for message broker already. It really differs between the message broker implementation, but let's assume it's all done perfectly already and we don't need to worry about that. Let's say we have chat 1 with user 1 and user 2. We got a message for this chat 1. We resolve it. We see user 1 and user 2 needs to be updated. We send a message. 2 different physical queues are going to enqueue this message. Gateway node, upon connecting the users to itself, it needs to subscribe to all the queues that the users it has right now. So user 1 connects to gateway 1, it needs to connect to user 1 queue. Same happens with user 2. Yeah, of course, it can be single queue physically, like physical server, but has 2 topics. That's generally true, but let's say we can scale it like infinitely. The problem is not with the queue as a bottleneck. The bottleneck would be still gateway node. So queue does not solve any problem unless it just brings more money burning in the system. Let's consider bigger case. So right now, let's say we have just chat 2 with 4 users in it. We are connecting to gateway nodes via round robin, basically randomly. Let's assume it's working great. So we got evenly distributed users connections. Now, all of these gateway nodes, they need to connect to every single queue that user is part of. Let's trace what will happen with the request. So chat 2 got update. We see that user 5, 6, 7, and 8 are interested in this message update. So we'll fan out it to every possible queue, which is already kind of so-so approach. But the problem is that every gateway node still needs to pop it from every single queue it gets subscribed to. So in this case, gateway 2 subscribe to queue user 6 and queue user 8. It will get consumed 2 messages, message from user 6 and message from user 8. Do you see the problem? Before that, in this simple scenario for single chat, these gateways would process only single message. But now, every single gateway is going to process much more messages, in this case 2, because we have 2 different users connected to this gateway. So this makes it even worse approach, because gateway node right now is going to process even bigger number of messages. Let's say, I'm not talking the queue is here as a bottleneck. The bottleneck is still gateway. So gateway now, for single message, for 4 users, This gateway node should process 2 messages from these 2 queues, and this gateway node needs to process also 2 messages from these queues. Now let's say we are going to scale gateway nodes. Again, not more than participants in the chat, because apparently these are our requirements. Now let's say what happens. Due to round robin, we evenly distributed user connections. It's all great. We have connected gateway node to unique queue per user. And now what happens? Yeah, we actually, in a sense, make gateway node to process less messages than before, but it's still every gateway node will process all the messages from large chat. With the fact that we have more chat participants in the chat than gateway nodes, every gateway node will have at least one user from the chat, which make it to connect at least to one single queue, which will make it to process the message from this queue. So it's not any better from direct insertion, apart from it can hide the latency quite a lot if we got too many messages in the queue and like consumer didn't keep up with them. On top of that, we get more money spent on the queue broker, deploying it and stuff like that. So this is definitely not scalable approach. We still have gateway node as a bottleneck. It doesn't solve anything. This is a bit larger diagram here. So we have 12 users, 3 chats, and we have 4 gateway nodes. You can clearly trace that all the gateway nodes are interested in all the chats in our system, because again, we have more than or equal number of participants to number of gateway nodes, and queues are not solving here anything completely. It just nothing, it solves nothing. You can tell me that, yeah, these topics can be single queues, even if I partition it by chat as well, the queues themselves. It won't solve anything, because logically these will be separate topics, and gateway node still is going to process every single message from every single topic separately. So this is not scalable approach at all. So this approach is bad. Redis PubSub is even worse, because it doesn't have any delivery guarantee, so you have no way of understanding in your system whether a user got the message notification or not. Well, Kafka is too expensive for this type of things, because you're gonna have all the topics per user. And HelloInterview has a very good point about this. If we change it to RabbitMQ, MQTT, in case we can afford these queues per user, or sorry, topics per user, it still doesn't solve our problem. So just keep in mind that. And of course, I did a simulation for that. So PubSub by user, let's see how it works. We have again one chat, 10K users per chat. We're gonna have 1K of gateway nodes. And these are shards. This is irrelevant. Sharding by chat should be pretty fine. What results did we have? So now gateway nodes processed actually more messages than in previous solution. Why? Because exactly this case. Now we need to process each message per user, not a message per chat for gateway node. So in this case, it's only for the same chat for these 2 users, but we're going to process twice every single message separately, instead of processing it as a single entity and it just fan out twice. So yeah, it doesn't look good at all. It doesn't look good at all. It doesn't look scalable linearly at all. I just showed you why. I just scaled twice as much. It will work the same on the big numbers, because the only thing matters is how many users will be per gateway node for single large chat. If this is more than or equal to 1, it means this gateway node will be interested in the messages from this chat, and it's going to process it. And it will be more than 1 in case we have much more participants than gateway nodes. That's a rule, that's a must. You cannot oppose it. As the last approach that I've seen, let's consider queues per chat rather than queues per users. You again see gateway is a bottleneck here, because again, gateway is going to process all the messages from the chat, but at least it will be much better than queues per user. And I will show you why as well. So again, let's consider and trace down our flow. We got the message on the chat 1. We resolved, okay, user 1 and user 2 are interested in this message. Now we're using message broker and topic per chat. So chat is going to have messages. We have a message here. Gateway node is subscribing not per user, but per chat. So in case these 2 users are connected to this gateway node, we still have only single connection to chat, because gateway node is smart and it knows that, yeah, if these 2 users are in this chat, I need only to subscribe to this single topic, as simple as that. So right now, yeah, we got the message, gateway node process it and fans out it to clients. Simple. Let's try with larger chats. Again, we have our simple scene with chat 2. We have user 5678. So we got the message, we enqueued it to the chat. We have two consumers. They both process this message and they fan out it to the users. Again, for this simple case, we can clearly see that both gateways need to process message from this large chat. Again, we are trying to scale it more, as gateway is our bottleneck. We don't consider queues even. Let's say we scale gateway node by 2. We have now 4 nodes. Again, in case we have more participants than the number of chats, than the number of gateway nodes in single chat, it means gateway node will be having at least one user in this chat. It means it is interested in this chat and it will be processing the messages from this chat, which is the bottleneck here. So in this case, one single chat enqueued. We need 4 consumers to consume these chats because all of them have at least one of the users that is interested in this chat and it needs to get the delivery. If we try with larger chat, we again see gateway nodes are interested in all of these 3 chats, so they are going to process messages from all of the chats. Again, on the larger scale, it means since if we are going to add more chats, no scaling of gateway nodes will help us with scaling the CPU or RAM usage at all. Like the scaling benefit will start only after we scale to the number of gateway nodes, which is extremely larger than number of participants per chat, which is extremely expensive. Of course, I have emulation even for this case as well. You can check GitHub. I will mention it again. So in this case, we have, again, single chat, 10K users per chat, 10 messages in this chat inserted. Let's see what will happen with our gateway nodes. So queue notifications received, which is 10 per gateway node, which means it proves that every single one out of these 1,000 gateway nodes is going to process 10 messages each, which is not scaling. It is not scaling, guys. It doesn't bring you anything except more cost for queues. Now the queue can be overloaded. It will have latency and delay because, it will buffer the messages. It still might give you some delivery guarantees, which is good thing. If it's not Redis pops up, of course. But other than that, it's just more cost. It doesn't help to scale gateway nodes at all. So as I was telling you before, just throwing in your system a bunch of pops up queues not always mean that you are going to scale well. It's just the point, like, stop putting pops up as a solution to everything. It does not mean it will scale, guys. It does not mean that. Let me, clear it. Maybe it works in real production systems. Unfortunately, Telegram rejected me when I was applying to them, so I cannot ask them how they do that. Also, I didn't apply to Discord or Slack or something, but it's definitely not linearly scalable. Maybe, I'm not telling that we need to be linearly scalable here. Maybe being not linearly scalable is just enough. I was discussing with some guy and we definitely proved that, he definitely proved on the single AWS region that with some sort of batching and stuff, we can actually handle the network bandwidth here. So network will not be a bottleneck here. But the bottleneck will be CPU, because for every single message in your gateway node, you are going to do what? You're going to resolve all the users that needs to get an update, because you might have users from different chats. You cannot just blindly broadcast. Only this single thing would need you to have some sort of map, so you need to calculate hash, which is CPU intensive, and resolve your users. Then per user, you need to resolve the socket, or maybe you're already working with sockets rather than with user IDs. Can be, we can simplify this hope. But even with socket, now you have the bad network and bad data from the user clients, because I might have mobile data with like 3G, whatever. It can take ages to deliver me something. I have network interruptions and stuff. So you need to have a retries here. So you might need to have some exponential backoff, or at least just blind delays and bunch of retries, right? And this is all CPU. This is all CPU, guys. And this is for each user. Yeah, you can parallelize it, right? But still, it will be burning a lot of CPU, and it does not get better anyhow with scaling. Again, this is per single message. We are going to traverse all the users that are in your gateway node that are interested in this message. This is not linearly scalable. We are scaling gateway nodes we again need to process message here. So what do I propose as a potential solution in this case, and how would I answer this if I'm having this system design problem? So first thing, of course, we probably need to shard it or distribute it by different property. We should stop connecting based on user ID and start connecting based on chat ID. So what I propose, extremely large chats are handled completely different. So when we know that this is large chat, we are going to connect to special chat gateway nodes per chat ID. So most probably we cannot do it in a randomized way. Instead, we need to do a deterministic way of having stuff. So we're gonna have consistent hashing ring with chats assigned to gateway nodes. So once user needs to understand where to connect, this thing would tell it, okay, you're from chat 3, this is your gateway node. It doesn't matter which user you are. So this will give us picture something like that. Now we have single chat that handles the messages, and basically all 10K people are going to be connected to this chat. And we can distribute it up until we have single chat per chat gateway node, which will be definitely enough even for 200K. Okay, maybe 200K will be too much, but for 10 or 20K of people, this thing can handle it, no worries, like without any problems. So how the flow will work now? We got the new message into the chat API. We resolve what chat gateway node we need to talk to from this storage. We send one single message here, or update here, and this thing just broadcasts it to all the users in this chat. In the extreme case, it's going to handle only single chat, so it can be just pure fan out until it's delivered. Now showing you how it is scaled if we scale it twice as much. So let's say I removed the users from here. Now we're operating over chats. Let's say we have 6 chats and only 3 chat gateways. We definitely see that this guy handles 8 connections because we have 4 users per chat. This guy handles 8 connections, this guy handles 8 connections. Every one of them is going to receive messages from chat 1 and chat 4. Now let's say we are doubling amount of chat gateway nodes. This is what we get. We got scaling point on this case from chat to chat gateway. So number of fanouts decreased and number of incoming requests also decreased. So this is linear scaling. This is how it can be done. This is the solution that I would accept and tell, okay, this looks good. I definitely see, I really see how it can be scaled. This is like literally, here it is in my Escalidro. What is the problem, guys? The problem is I actually checked network tabs for Telegram, WhatsApp, Slack, Discord, and to my surprise, they're using only single socket connection. So, interesting point that most probably they're using something like that. So most probably they are somehow round robin or evenly distribute the connection to single server, and this single server or gateway node, whatever, it handles the users no matter how you change the chat. So I was actually changing the chats in the application and observing whether I get new connection or not. Because definitely in this solution, if user from chat 1 switches the chat to chat 2, the user should remove connection from here and actually connect to this chat. So I need to see the reconnection from the WebSocket. Unless I'm connecting from chat 1 to chat 4. In this case, reconnection is not needed. But I clicked like 10 or 20 different chats. So I definitely had to see at least one reconnection, right? But it didn't happen. That's the problem. I actually don't know how they do this. I really want to get to interview to any of these companies just to ask them how they do this. I'm genuinely interested. I never seen any solutions, any metrics, any data about is it a problem at all. Maybe the problem with scalability, that gateway nodes are not scalable, maybe this is not the problem. It can be that they're using some extremely complicated nerdish algorithm of fanning out with some bunch of retries. That is not the problem. Maybe there is no bottleneck of how many large chats you have. Maybe they, no matter what, they always have enough capacity in CPU, and even if all the human beings are using this chat service, are they're all in the large chats, it won't be a problem. I don't know, I don't have data. They don't publish good data. I cannot understand it. I don't know what code is executed on each of the gateway nodes. So maybe I'm wrong. Maybe, yeah, we don't need to be linearly scalable. Maybe they do it in some way that I don't know how exactly, so that it is linearly scalable. So maybe only 2 options I see here. maybe being not linearly scalable is not a problem. Or second thing, maybe they do it some other way that I don't know and no other people know. Yeah, and I'm just dumb and I don't know how they do this without reconnection. Both of it can be true. So I don't know. This is the open question for you in comment section. I would appreciate your feedback and generally interested in your thoughts. Okay, thanks for being with me. I would really appreciate your feedback or your ideas how they can do it because so far no one in any forums provided me with any good answer that would actually seem legitimate to me. Also, please don't forget to subscribe to my social media. I'm posting here about my life in Ireland and as a Snowflake engineer, posting different interesting stuff about networking, system design, lead code. Also, you will be able to vote for the next content area that I'm going to work on. It was me, Andrei, and see you.